New edition of the Heat Treat podcast. Today we have a great guest, a personal friend of mine, and one of the guy that you want to have in your heat treat shop if your system goes down. He really knows how to fix stuff, teach the customer, and he's a great computer engineer, Mr. Bill Heckman. How's it going, Bill?
Hey, Carlos. I'm doing real well. Thanks for having me on today.
No, it's an honor to have you here. You know, you have been a great teacher to me, a great mentor when it comes to computer engineering, computer design, SCADA Systems. You're always there for us. I just want to thank you. I've been working with Bill for maybe 15 years now. He was my teacher, my mentor when it came to instrumentation, computer engineering for furnaces, PLCs, all that. He's the guy that really knows the stuff. And I just want to set the bar high because I have a bunch of respect and friendship for you, Bill.
Oh, well, thank you, Carlos. The respect and admiration goes both ways here. It's been a pleasure to work with you for, I guess, 15 years. I didn't know been doing this, but it's been a good friendship we've been able to develop, and it's been a good career being in the heat treat industry for myself personally.
Good, great. So today we're going to talk about SCADA systems and controllers. Bill is an expert on the subject. Of course, SCADA and Industry 4.0 is one of the big trends now, and Bill has installed hundreds, if not maybe thousands of systems worldwide. He's been in many countries, including Mexico, of course. He's been on our shops. He's been with some of projects that we have worked together. And he has had a very long career on SCADA's instrumentations. Of course, he's engineering manager for Super Systems Incorporated in Ohio. But he has helped develop a bunch of softwares, comms programs regarding how to get information back and forward from the controls, from the instruments, and actually display them on computers. But he's the expert. I mean, I'm just here to introduce the guest. But Bill, why don't you give us an introduction about who the awesome Bill Heckman is, and his wide knowledge about computer engineer, because it's true, and Bill is very humble, but he's an A player in the industry.
Okay, well, don't know if I'm the awesome Bill Heckman. I'm still out
there. You are.
That who comes up with that one? But again, thank you for the introduction and everything. As far as my background, I started in the industry back in I graduated college way back. The year was 1993. So didn't really think about it till recently. I was like, wow, I've been in this industry for quite a long time, and obviously I've enjoyed the work and the people I get to work with on a day-to-day basis. But started back in 1993 with Marathon Monitors. I'm sure most of our listeners are familiar with that. So really started off working there, mainly their instrumentation, working with a gentleman who hired me, was a very smarter man than me, Clark Goodman. Clark's retired and moved on to better things now, but started off at Marathon mainly working with Dual Pro instruments, if anyone remembers those. So a lot of programming of those, writing custom applications for those. Got into the what was called Process Master at that time, and really started getting more into the SCADA side of things and doing systems integration of instrumentation and furnaces into SCADA systems, and kind of grew with the industry in that regard. Worked for Marathon up until about 1998, 1999, when they decided to get out of the systems business. And for about a 2-year period, we were, myself and a couple coworkers, we actually worked for, AFC at the time, AFC Holcroft now. We worked for them for a while. And then in 2001, the opportunity came along for Super Systems to hire myself and a couple guys back on into their team. And I guess you say the rest since that has been history. So I've been working with SSI since 2001. So
20 years.
Yeah, it's a long time.
Yeah,
time flies when you're having fun, and it's been a fun time, been a fun ride.
And and you have been mostly working on systems, right? Because it's very different from working on retrofits, on instrumentation upgrades, instrument upgrades, or systems involve a quite variety of communications between instruments, a PLC, a smart instruments, and a computer, right? That's what your core is, isn't it?
Yeah, I mean, I guess my role within SSI here is work within our systems group. So we're the guys that get to take all the fun toys that we develop at SSI and products and put those together for a solution for our customers. So they will include instrumentation, PLCs, any automation programming we need to do. In addition to, SCADA systems, could be just a furnace specific application or, plant-wide type applications. So that's kind of the role here within SSI is, we do part of what we do is retrofits and systems integration and, multiple legs of the company here, but I tell the guys we could take all the fun stuff, all the toys and put them together and, come up with a solution for our customers.
Great. So today we're going to talk about mostly about SCADA systems, what they are, what they're used for, what are the most common misconceptions, the integrations of those systems. We're backing up the data correctly, right? Because we live in a world of data, and Bill has a bunch of experience on the subject. So Bill, can you explain to the audience what's a SCADA system on a very basic level, first of all, and then we can move there after to the integration itself. But first of all, let's go to the very bottom line and explain what's in SCADA system.
Yeah, so basically SCADA, that's an acronym. It stands for Supervisory Control and Data. I think it developed out more of the control room situations. We seeing the big power plants or oil processing facilities. They have a centralized control system where they're monitoring all their process data, and in those situations, they're able to maybe turn things on and off. When we're talking SCADA more within the heat treat system, it's more about communications and data logging. You're centralizing all your data. So think of your typical heat treater, you're going to have multiple pieces of equipment. Each piece of equipment is going to have at least one controller or may have more or multiple controllers, things such as a temperature controller, an atmosphere controller, an overtemp, maybe even a PLC. So you have these individual pieces of equipment and individual devices within that individual piece of equipment that are doing their primary function. Again, the device controllers, you're either controlling a temperature or you're controlling an atmosphere or a gas flow or a pressure. So all these devices, anymore, they're smart devices. They all have microprocessors. They have ability to maintain setup parameters, run PID loops. Some of them can do some of their own local data acquisition, but at the equipment specific level, you have devices there that are doing multiple functions for your process. And then what we do is with a SCADA system is you're now going to take, you're going to tie in all that equipment, the devices on the equipment, you're going to bring that into a centralized PC. And what we're doing at that point is then you're giving your customer the ability you're kind of giving them a switchboard where all this process data that you're bringing in, you're logging all that information on your local on the PC. And now that data is available to view not only on that PC, but you have other PCs, the software is there where you can have 30 or 40 PCs in your heat treat where everyone can see what's going on at any point. So really the SCADA allows you to it's centralizing all your data instead of having, your operator has to walk to furnace to furnace to furnace and see what's going on in each piece of equipment. Now they can go to a PC and we can have a centralized HMI developed for them that they can view all their process data from one location instead of having to go out to individual equipment. It saves a few steps and makes, saves you some time as well. So in general, SCADA is just taking all these data points you have from all your equipment, bringing it into one central PC, and then can be distributed for anyone to view what's going on out there.
And now that you just explained this really briefly, there's a bunch of science behind it, but I believe Bill did a great job just explaining the basics. But the real challenge is to getting to talk and centralize all the toys like flow meters or fans or motors or switches or let's say burners, PLC together, because everything has a different language, everything has different signals. You need to have that centralized somewhere and send it to a PC, and that data converted in a way that we can actually watch the data how we want it, or even display images. Could you go deeper into that statement, Bill?
Sure. I mean, we can dial down into what does it take to connect these devices and things like that.
Very basic, because I know this can get very, very complicated, but
Sure.
I don't think most people know what's like the big challenge is to have these things talking to each other, because they're all different.
Sure.
Can you explain a couple examples?
Yeah, so the basic thing is, again, comes down to you have to have the controller at your piece of equipment. So a very common piece of equipment probably everybody knows about, let's say a temper furnace. So a temper furnace, you're going to have have a couple thermocouple. Thermocouple comes into a digital controller. That digital controller is controlling the process. And most controllers that are in the industry today that you can use, they also support they support communications or protocols, basically a common language. And within the heat treat industry, the most common protocol or language that's out there is a protocol called Modbus. There's two different types of that protocol. There's Modbus Rtu, which is serial communications. When I say serial communications, that's basically a
this is where the stuff starts to get complicated, and this guy knows this stuff, right? That's what we're talking to him.
So the way you connect these devices is either going to be the way you think you got to have some line of communication, and that's either going to be through some type of cable, either what's called shielded twisted pair, or what most everybody is very familiar with, which is something like this, an Ethernet cable, and that would be what's called Modbus TCP. Those are probably the most common languages that are out there, and those common languages is what you need in order to tie into your SCADA system. Really what the base of SCADA is you have some type of communications driver. There's multiple SCADA systems out there. With SSI, we sell our Super Data product. There are other products out there. There's Iconics, there's Allen Bradley, Wonderware, Siemens, and there's a multitude of other third-party software out there. And really what they all come down to is the core thing is communications. And so how do I communicate to this device? Well, it's either going to be some type of either shielded twisted pair, as I said, or it's going to be typically it's an Ethernet cable. That's how you tie everything in together. Is you have you've got a physical connection somewhere where it takes your PC here and goes over here to your field equipment and ties it all in that way.
And I believe there's a bunch of softwares or systems, or even you can make your own. Let's say Linux, right? But the added value that SSI brings to the table is that they're a company that knows how to do all this, but they're furnace experts, right? It's not the same if you bring an integrator to do a SCADA system for a heat treat line, right? Because their applications can be very wide, but SSI just focuses on the heat treat industry, because furnaces can be risky if you are playing with them from remotely, right? Even if you're controlling them. So I believe that's a great value to have a team like yours that are devoted to the heat treat industry, and they know how to make things happen. Talking to a furnace, doing the comms, but at the same time you're controlling the furnace that has a valuable load. Or if something goes, we do a malfunction on the PLC, on the mechanic systems, we can even have an explosion or a jam. But now let's go more into, now that you explained us also the what's behind the screen that we see on our heat treat department, all the modbuds, all the comms. What do we want to see on the displays? The process variables. They're very simple process variables to very complex process variables. There's also tray tracking. So there can be very simple SCADA systems, but there can be very complex SCADA systems. What's your experience with those?
Yeah, I mean, there's a wide variety. It comes down to what the customer wants to do with their system. So we can start off with a very there's multiple levels of a SCADA system. Everything starts off with that first base layer or the foundation, which is
the temper furnace, temperature, and a high limit. That's like the most basic one.
And for some customers, that's a great start. And that's, a lot of customers, they just need to have they need to be able to prove your process. Really what this comes back to is, all of our customers, they share one thing in common. They're going to get audited by their customers or standards that they have to meet. And one of those things is going to be, can you prove this process? So the SCADA system helps you prove that process. All that data is stored locally. It's stored on a hard drive. It's digital. It's encrypted. So the data is there. But, get back to your question, I guess, starting from the very basics to the more complex, everything still comes back to communicating, getting that data. So with our temper furnace, I've got temperature set point, my actual, my percent output, and maybe a high limit. And I got that data coming in, and I'm pulling that data in, and that's great. Some customers, the next step there is maybe automation, because, their customers, they run their temper process. Sometimes they're just looking at a clock, or they're setting a manual timer in a door. So depending on the level of automation, it depends on how much more we do with the SCADA. So if you put a programmable device on that same temper that can run what's called a recipe or a process, now you can add another level of capability to your SCADA system, in that now you can communicate to that controller. You can download all your recipes to that controller, but allow the operator to start that cycle manually at the furnace, allow them to run the cycle when they load it. So that's, taken from the very base level of, I just got this controller and I'm pulling in all my process data. Now we go on the next step is I want to control my process. And our SCADA system allows us to do this, because it allows you to manage those recipes from a PC. You can push them down to that device, and your operators don't have to worry about creating a recipe or starting the recipe. They just have to enter a number, and then they're off and running. The process runs. And, the automation, the recipes give you the added benefit of having a repeatable cycle, and a repeatable cycle, and an accurate cycle, and a traceable cycle. Those are all things, a lot of customers are looking towards doing these days. And so, you got that level. If you want to take it up another level, there are systems. We have a system we call our load entry application. There are other suppliers out there that have similar systems. And with this load entry system, now you are building upon not only the process controller, but the recipe controller. Now you're adding the ability where you're going to be recording every load that you run in this particular temper furnace. So you have a start time and an end time. And from that start and end time, now you can create a report with a graphical trend chart with it. And that load entry can also allow you, I'm going to pick this part number, and the part number automatically picks the recipe. And that starts the cycle in my process. And again, what you're doing is you're trying to eliminate any possible errors, human errors, that is, with processing that load. So when it depends on how advanced the customer wants to get. Some customers are fine with still having manual cycles, but we're recording it, and that fits their needs just fine. Other customers want to go with a little more advanced system, and we have the ability to provide that and the experience to do that. It really comes down to what the customer wants to do, and that comes down to a conversation of managing expectations and having those conversations up front. And hopefully when we get an order, that's the first thing we happen. There's a conversation that happens, and you review all that.
And from working with you these many years, I think that most of the time the challenge is to cover the expectations, because customers might have an expectation in their head, and they try to communicate it to you. At the very end, they have a very functional system, but you don't get the load doesn't blink when there's a jamming or something happens, and the customer expectation was that that specific load blinking when something happened. And it's doable, but it's very tailor-made to the specific request. When it comes to a very extreme system, right? A very complex system, right? So and you and I have been in shops that in and out installing a SCADA system, just plug and play. But we also have been on projects that last for 2 years because the customer's expectations are very different. What do you think is the best way for a customer to express what they need so they can actually get what they're expecting?
That's a good question, Carlos. Very good question. Usually those conversations are happening on the sales side of things. Usually, our sales staff will bring in myself or members of our systems group to have those technical conversations early on in the process. But then once we get an order from a customer for a project, if it involves a SCADA system, there's typically a conversation that we have with the customer and say, okay, here's what was purchased, here's what we're going to do. We write up a design document for any HMI SCADA project that we do. We'll write that document up, we'll send it to the customer and say, here's what we plan to do. Just so, and it's all about making sure we're maintaining expectations, and we try to get that flushed out early. So, we don't show up on site with the system we fully developed and it's like, well, what about this feature? I thought we were getting that. So it really comes down to really having that open line of communication with your customer from the get-go of a project and keeping them involved in the design process, as we're writing our specification up, and then as we do our development, provide opportunities for the customer to either log in and we do a review of the software we developed, or provide screenshots we've done so far. And I've found that to be a pretty good strategy, working with our customers to make sure we're providing what they need along the line. And it's good for us as well, because again, we don't want to end up in a situation where there's different levels of, we were doing this, we were expecting this, or one way or the other. So.
And I believe most of the time customers, they're getting the data they want, but they expect more aesthetics or I remember this customer that wanted his logo on 3D, just like swinging on the SCADA system, and that's doable, but that takes a bunch of I'll say illustration or design that is not related to heat 3D engineering, but they also look for the aesthetics. Do you get that a lot?
Every once in a while you get it. I mean, we that's why we try and get our customers involved in the design process earlier.
Right.
So if something like that does pop up, it's easier to fix it in-house than it is on site. We jobs maybe 80 to 90% complete, do as much as we can office before we show up on site. And in doing that, we're in touch with the customer, make sure we check boxes of your expectations.
And also there's I believe this is also a great tool that when it was invented, you got a lot of less traveling, which is that you can remotely logged in from your office, you can remotely logged into the heat treat shop and fix a bug. And that has been like a great asset and a great victory for guys like you, not to travel that much and being able to service the customer right away. Because if you were to, you're based in Ohio, but if you had a customer in California that required computer assistance, you will have to take a flight there, maybe a couple of days, and start watching the problem. But with this internet era, you just can log in, and it's always like very tiny adjustment to the program or the configuration that make things happen. So what's your opinion on that one?
Well, that's been a huge game changer for us, to be honest, Carlos, and that's a good point to bring up.
That's why you and I don't see each other that much, because 20 years ago, we didn't have these tools, and you and I spend a bunch of time traveling, but we barely see each other right now, because every time we need Bill's help, he just logs in.
Well, it allows you to be in multiple places at one time in one day, Carlos. It's a real benefit, for SSI and also for our customers to be able to respond quickly to issues. And like I said, a lot of times sometimes there are simple changes, and just getting online and seeing things.
I would say, maybe correct me if I'm wrong, 90% of the time are simple changes.
Yeah, I mean, a lot of times something as software is not like changes happen that often, or even furnace specific stuff. Everything's pretty repeatable, so it's not like there's a bug. I'm not saying we don't have bugs in our software. There's always going to be bugs, but the system's been running for a while, and all of a sudden there's an issue. Okay, what's changed in the system? We got to dial back and figure that out. But to get back to the remote access, that's something we probably have started using probably almost 10 years ago. With just being able to get remote access, as internet became more and more prevalent, and capable, being able to get that remote access using any variety of there's all sorts of remote access programs out there. Having those tools available really is a benefit, to our customers to be able to, I'm having this problem, even doesn't have to be a SCADA related thing. It could just be a furnace specific issue, but our SCADA system helps us diagnose furnace issues. So it's nice to just be able to log in and see what's going on. Okay, well, this was going, you can usually make some recommendations to your customer to address not only SCADA related issues, but also furnace related issues. And, so the remote access has definitely been a big game changer. Especially, going through COVID, that probably even became more and more important, being able to remotely support customers. We were still traveling and seeing what customers that we could, but, the remote access is definitely a big benefit to, both to our customers and to SSI, and I'm sure to, any other suppliers in the heat treat market. This remote it's just a great game changer, and
it is.
Allows us to be more responsive to our customers, which is in the end is what we have to do, because if they're not running and making money, then they're not, not got the funds to, work with us to do more projects. So it all feeds together.
So now let's talk about data. So SCADA systems are in order to, read data, supervise data, acquire data, and the data gets storage. And that's, I believe data is overrated right now, because we're backing up a bunch of data that we don't even know how to read or use. But that data has to be backed up somewhere. And we have also the hardware situation where the hardware can break down, can be damaged, it can be erased, or even we can have, and I don't want to go deep on the cybersecurity topic, but the data can also be lost or rich, or and I don't think this is a case for heat treat. It's not like there's a WikiLeaks for heat treat, right? Who's using which recipe and what? But there's a concern that cybersecurity is also a big part of the stuff. But what can you tell us about the data? The most common mistakes that you see, that you don't back up the data, or the user don't back the data up, or they just erase it. What can you tell us about data on the whole SCADA topic?
Sure, that's a good question. So obviously we have this we have a PC that's running a communications device, and that's collecting data from all your devices out in the field. And that data is being logged typically to the local hard drive on the computer. That's probably 98% of the jobs we do. Everything's local to the PC we have the software installed on. And just so, the logging process at all, there's AMS 2750 is a big one for a lot of our customers. And part of that requirement is digitally and encrypted data. So, if there's anyone out there looking into doing a SCADA system, that's one thing you gotta make sure you're gonna be able to is meet those compliance requirements with the quality systems such as AMS 2750. So you're collecting all this data. It's all pertinent information that we want to collect from the PC. So as far as issues, once that data is written to the hard drive, it's written to the hard drive, and you can't go back and modify it, which is, it's a good thing. As far as any type of mistakes or anything with data, the biggest thing, I guess, is what I always caution and coach our customers on is, you've got this SCADA system now, you're collecting all this data, 24 hours a day, 7 days a week, 365 days a year. If your heat treat's running, you're collecting data. What happens if you lose that data? So you have to have some type of mitigation in place. And for a lot of customers, what they do is that PC is not only on your heat treat network, it's also part of your business network. So we just work with our customers to say, here's the files or folders that you want to make sure you're backing up on a daily basis for your data. And the reason why you want to do that is, I've had, unfortunately, there's been some customers over the years where they've had the system been running fine, it runs great. You don't necessarily think about it until something goes wrong. And usually when something goes wrong on a computer, it could be a power supply, it could be the CPU goes bad. But that system goes down. Now there's a bit of panic that sets in because you've just lost that information. So the biggest thing is just make sure you're backing up that process data that you're collecting. When we work with our customers, we say you need to make sure you're backing up at least once a day. That way you have no more than a 24-hour gap of any lost data. So that's probably the biggest thing I say, just make sure you're backing up your process data. You have to worry about either hardware failure or, unfortunately, we've had some customers that have gotten hit with ransomware or viruses. And that's a difficult situation for our customers to be.
I believe one of the biggest mistakes, and correct me if I'm wrong, Bill, is that they have their SCADA system, and sometimes customers use them in order to do other work. And it's a computer; it can handle it, right? But they start downloading stuff or installing other programs, and I don't know, just surfing on the web. But they're starting to get in some viruses on the PC or installing some programs. I believe that's a common mistake that heat treaters make when dealing with a PC that runs the SCADA. Do you have an advice on that one?
Yeah, I guess my advice is, I think that used to be an issue maybe 5 years ago. I think a lot of our customers have gotten much more savvy to that now. So we're either dealing with their own. A lot of our customers they've blown up, I guess you could say, and they have either a dedicated IT professional or they have an IT provider that they work with. And usually one of the things that IT professional does is you get these backups going, and then they incorporate some type of security on their on these mission critical machines. A lot of customers, when we say our data collection system, they usually want to take that PC where no one has access to it. So all you have is workstations accessing that machine. So I guess that's one thing customers could do to protect themselves is, we got your primary data collection PC, make sure that's not somebody's primary operating day-to-day PC, dedicated hardware. Or, a bigger push recently with, is a lot of customers are going to virtual servers now, which, that's fine to us. The software we runs on a virtual machine. It's just, there's no physical PC there that you're running with, but the benefit of a virtual machine is it's basically guarantees you 100% uptime as much as possible, much more so than a physical PC would, but either solution works. The biggest thing is really just putting the protective measures in to protect yourself from, a possible virus. And, like I said, most of the customers I work with anymore, they've either suffered through that once already, or they've been proactive and they have the action plan in place to protect themselves from instances like that. So I guess that's my point of view on that one.
Thanks, Bill. So we've been talking about SCADA systems. Now we touch a little bit on the technical. We talked the basics. Better general technical. We went into some of the most common mistakes I see. Do you think we're missing something, or there's something we're saying, maybe a misconception of what it is, maybe the most typical mistakes that you encounter, or easy fixes that can make your life easier, the user easier? Did we miss something about SCADA systems that you would like to share?
I think we covered the basics there. The main benefits, again, you're looking to have traceability, repeatability, and be able to measure efficiency of your heat treat. And it all comes back down to having that data. A common term you hear anymore is like data mining. And stuff you can do with your SCADA system. It's as long as you have communications and you have all that data somewhere, either on a local hard drive or stored somewhere else, that data is there. And so how can we use that data? We're using it for looking at it for trend charts. You're looking at it to prove your process. The growth at SSI since I started here in 2001 was, we basically sold a data acquisition, trending, and HMI system. And over the years now, we've developed other add-on modules onto that. So, and it's all based off of it's customer driven for the most part, but it's also driven because there's two words that heat treaters don't like to use, and that's scrap and rework. And, a SCADA system, if we set it up and we develop it correctly for our customers, it's something that helps reduce the capability of having scrap or rework. And that comes back to, what do you want to do, and what modules, how can we work with a customer and provide a situation that, helps prevent that. And a lot of that comes down to, adding the extra software to give you that ability. I mentioned our load entry software. Again, there's other companies have other solutions, but it's an integrated product that allows you to manage all your recipes, manage your parts, manage your personnel, manage all parts of your heat treat through the software. And then you start all your cycles through the software. And that's all through your SCADA system, all through communications. And doing that, now you're getting repeatability. You're running the same cycle every time. You're running the same process every time. So you should get good results outside of any physical things that happen with equipment. That's the other side of heat treat. Everyone, you're well familiar that these furnaces are living, breathing things, and they break down just like we do from time to time.
And I gotta add something to your comment. For us, for the heat treats I run for Creo, what I gained the most out myself as a manager is the utilization and of each furnaces and on the total shop, right? It's something that you sometimes do believe your furnaces are more utilized than they are, but numbers don't lie. So if you get a good algorithm and the computer just throws out the data, numbers don't lie, and they say like, hey, you're running one or two more furnaces that you need. I mean, you can save money, or you can shut down the furnace. I mean, for me, that's the biggest part of it. Of course, when a customer comes and they see a nice, big screens and nice data and charts, they see, I mean, these guys know what they're doing. I mean, you show technology to the customers. And of course, as well, if there's a quality problem or an audit from a customer, you can have your trends, all of your past data from, let's say, 2 or 3 years prior, well organized. And if you show to them that you have that data in control, that you know where to find it, they ask for a particular lot, and you're able to do that, you gain a bunch of trust from your customer or the auditor. For us, for me itself, I'm a true believer on investing on technology, on this type of softwares. You have to keep investing, because if you bought your software 10 years ago, there are a bunch of new features that there right now that there weren't, and there's a bunch of new features that there are going to be.
Oh yeah, I mean, I always joke with our software team is like, we're going to be done with that program, just because there's always, someone always has new ideas to apply to a product that we come out with, and we get a lot of good feedback from our customers and our sales channel of how to improve our products and make them better. Obviously, quality standards are always changing, so we have to adapt. And as a supplier to the heat treat market, we have to make sure we are giving products out there that are helping our customers meet those ever evolving, you could say, specifications. Seems like as they need to. I mentioned data mining a little bit ago. We do have the abilities of a program that will allow customers to view any piece of data and determine, you're talking operational efficiency. They can determine how efficient am I running this furnace, or how efficient am I running an entire group of furnaces, and how efficient am I running my heat treat. That's all based off of the data you're getting from your SCADA system. We've got one customers where they actually have they had us create a big bulletin board HMI screen that showed them all their equipment and how efficient they were running for the week. And as they put that out there, so their employees realize, hey, we got to be in the green line. We don't want to be in the red line. We want to be in the green this week. Those types of things. That's business intelligence that you hear about. Another thing that is that we've used that data for. I've had customers tell me they've actually used that to get funding for furnace retrofits. Customer a couple of years ago said he got a funding for a job because he's able to prove that one furnace had been retrofitted. It used 30% less utilities and gas than one that hadn't been. He was able to prove to get funding for a pretty substantial project. Just collecting the data, having trend charts is very good, but we've at SSI and I'm sure there's other companies out there doing the same thing. Is the business intelligence side of things is kind of the next step of where I see this going is. You have the day-to-day operations, which is good, but the management tools are just as important as the day-to-day, and providing our customers that ability is that's another thing that we're able to do based just off of our SCADA system.
Thank you so much, Bill. Bill, it's been a pleasure talking to you about SCADA systems. From the experts to the world. That was the awesome Bill Heckman talking about SCADA systems. All the technical side, like the comms. We talked about Modbus. We talked about the wiring. Ethernet. We didn't get very deep. I have had a bunch of conversation with Bill, and trust me, this stuff can get very technical. We didn't even touch PLC stuff. Maybe for another podcast, Bill. But
Sure.
It's been great. We have to keep it lean. Bill, just before we end the show, personal advice or personal experience that you would like to share through the new generation of heat treaters that you would like to share with the audience right now?
Okay, that's a good question. Another good one there, Carlos. I guess I'll think of advice. There's a young man I've known through different avenues through Boy Scouts, young man now, and I was talking to him about a month ago, and he's just getting started in his career. It's an industrial field, and I said, a couple things is, don't be afraid to ask questions. Don't be so feel that if you're asking a question is a sign of weakness. I tell them it's a sign of strength to be able to know. I don't know this, I need to ask for help. So never be afraid to ask for help, because what you'll find is there are more than a handful of people want to help out, answer any questions you have. Don't be afraid to get your hands dirty. That's how you're going to learn. I started off at doing field service, and that was a great way for me to learn. So don't be afraid to ask questions. Don't be afraid to get your hands dirty, and don't be afraid to be an asset to the company. Take on those responsibilities and prove yourself. The only way you're going to learn is by doing, and it's okay to have some hesitancy within the heat treat market, the heat treat equipment. Be careful, but you can't be afraid to try new things either. Just keep you got to keep pushing the envelope forward, because the technology is always changing. So I guess that's a few things there for our younger crowd coming up, from the middle-aged dog to the young dogs. I guess that's my advice.
Thank you so much, Bill. Bill, it's been a blast having you here. This was the awesome Bill Heckman, because he's really awesome. He's a great friend. I just would like to tell the audience that we're uploading weekly podcasts on YouTube, LinkedIn, and Spotify. If you don't want to have the video capability, Bill just told us that he doesn't watch the video, but he hears the podcast every time he's walking on the woods. So thank you, Bill, for subscribing. Help me out and go like this, Bill. Please subscribe. Please subscribe right here on the link. Hit like, and we'll see you next week with another expert power player like the awesome Bill Heckman on the Heat Treat Podcast.